And to be the reporter number 27. So good day everyone. So I am Jasper S. Malapascua, and before I will go to the core topic of this reporting, so let's have first an overview with what is bituminous materials. So bituminous materials or asphalts are extensively used for roadway construction, primarily because of their excellent binding characteristics and waterproofing properties and relatively low cost. Bituminous materials consist of bitumen, which is a black or dark colored, solid or viscous cementitious substances consist chiefly high molecular weight hydrocarbons derived from distillation of petroleum or natural asphalt, and it has adhesive properties and is soluble in carbon disulfide. Tars are residues from the destructive distillation of organic substances such as coal, wood, or petroleum, and are temperature sensitive than bitumen, or bitumen will be dissolved in petroleum oils, where unlike tar. So one of the examples of bituminous materials are asphalt, and bituminous materials are considered to be the widely used or the oldest one materials, which was usually used in construction, especially in roadway construction. And also, bituminous materials are um, its main application is usually is for roadway construction, such as for pavements. And how does the bitumen or those bituminous materials produce? So, for the production of bitumen is the residue or byproduct when the crude petroleum is refined. A wide variety of refinery processes, such as the straight distillation process, solvent extraction process, and etc., may be used to produce bitumen of different consistency and other desirable properties, depending on the sources and the characteristic of crude oils and on properties of bitumen required. More than one processing method may be employed. So, for the production of bitumen was usually a byproduct or a residue of a petroleum, and its refinery processes, undergoes distillation processes and also solvent extraction processes, and so many processes, not only the two. And after it was produced, depending on the sources, the characteristic of crude oils and on the properties of bitumen required, more than one processing method should be or may be employed. So, what are the requirements of bitumen? So the desirable properties of bitumen depend on the mix type and construction. In general, bitumen should possess the following desirable properties. So the first one property is the bitumen should not be highly temperature susceptible. During the hottest weather, the mix should not become too soft or unstable, and during cold weather, the mix should not become too brittle, causing cracks. So, at the first property of the bitumen, in short, it should not be soft and it should not be also too brittle, because in hot weather or in hottest weather, if it is soft, it becomes unstable. While in cold weather, if it is too brittle, it can cause cracks. So the second properties of viscosity of the bitumen at the time of mixing and compaction should be adequate. This can be achieved by use of cutbacks or emulsions of suitable grades, or by heating the bitumen and aggregates prior to mixing. So the next property of the bitumen is there should be adequate affinity and adhesion between the bitumen and aggregates used in the mix. So for the test on bitumen, there are so many number of tests which can help to assess the properties of bituminous materials, whether it is good or whether it is suitable for construction or not. So these are the following tests that are usually conducted to evaluate different properties of bituminous materials. So we have this penetration test, ductility test, softening point test, specific gravity test, viscosity test, flash and fire point test, float test, water content test, loss and heating. But in this reporting, we can cover up penetration test and also what we call volumetric shrinkage. So, to proceed with our core topic or with the subtopic of the test on bituminous materials, let's have first move on to volumetric shrinkage, or it is a test on the volume of a bituminous materials. So, let's define first the volumetric shrinkage. So, volumetric shrinkage is the decrease in volume expressed as a percentage of soil mass when dried, of a soil mass when the water content is reduced from a given percentage to the shrinkage limit. And one of the analyses of bitumen requires the removal of water and sediment while impacting the bitumen as little as possible. In short, when one mixes 1 volume of bitumen with 1 volume of diluent, the result is less than 2 volumes of dilbit. This phenomenon is known as volumetric shrinkage. So, the definition of volumetric shrinkage is talks about the decrease of the volume of a soil or maybe of a bitumen, which it requires the removal of water and sediment. Um, it has a shrinkage limit, which means that it should not be high, or it should not pass over to the shrinkage limit, and also it should not be lower to the shrinkage limit. So in this volumetric shrinkage, we have this illustration to really determine or define the idea of volumetric shrinkage. So as you can see, before the shrinkage limit in this line, we have this volume of the soil remains constant. So if the water content does not passes through the shrinkage limit, volume of the soil remains constant. However, if the water content goes up and the volume of the soil increases and it passes through shrinkage limit, it means that the water content increases. Also, the volume of the soil increases. So, there are some factors or there are some effects if the volume of the soil increases and also the water content of the soil increases. So when the water content of the soil is further increased beyond the shrinkage limit soils, volume also begin to increase, as what I have said. So let's move on to the graph of the volume change over the water content change. So as you can see in this graph, as the volume increases, the water also increases. So at first, as you can see, if the volume of the soil or the material is not passes through the shrinkage limit, so it only says, or it only remains in a solid state. However, if it passes through the shrinkage limit, it becomes a semi-solid state and plastic state and also liquid state. So this graph shows the relation about the volume change and the water content change, which implies that as the volume increases, the water content also increases. So, to define the shrinkage ratio based on our graph, we have this shrinkage ratio is equal to volume 1 minus volume 2 over the volume shrinkage times 100 over the water content change 1 minus water content change 2, Or we could say that the shrinkage ratio is equal to volume change over volume shrinkage times 100 divided by the water content change. And for the effect of the volumetric shrinkage, so here it is. So some soils will change volume significantly depending upon the moisture content. This poses a special problem for the pavement design because this volume change can cause overlying pavements to sink down or heave up unevenly, potentially resulting in a crack or uneven pavement. Jones and Holtz estimated that shrinking and swelling soils cause about 2.3 billion of damage annually in the US alone. So it means if the volume increases or if the change in volume of the soil, it can cause a overlying pavements or sink down or heave up of unevenly, potentially resulting a crack for uneven pavement to the soil, which implies that it causes a negative effect to the soil, and it can also affect the safety of the people, or maybe it can also affect the construction operation. So volumetric shrinkage, also defined as soil shrinkage, is generally confined to the upper portions of a soil. Shrinkage and shrinkage cracks are caused by a reduction in soil moisture content through. So it means if the soil moisture was reduced, so it can cause cracks, and it was because of the number 1, evaporation of the soil surface in dry climates. Number 2, lowering of the groundwater table. And number 3, desiccation of soil by trees during temporary dry spells in otherwise humid climates. So, to get a summary about the volumetric shrinkage, it talks about the volume change or the decreases in volume. So in volumetric shrinkage or in soil, it has its shrinkage limit. And once it passes through the shrinkage limit, it can cause an effect to the construction operation or maybe to the material or to the soil, which is a very bad effect or a negative effect to the people. So, to move on with the next topic, we have this topic about penetration, or it is called as penetration test. To define penetration test, it measures the hardness or softness of bitumen by measuring the depth in tenths of a millimeter to which a standard loaded needle will penetrate vertically in 5 seconds. BIS had standardized the equipment and test procedure. The penetrometer consists of a needle assembly with a total weight of 100 grams in a device for releasing and locking in any position. The bitumen is softened to a pouring consistency, stirred thoroughly, and poured into containers at a depth at least 15 mm in excess of the expected penetration. The bitumen is softened to a pouring consistency, stirred thoroughly, and poured into containers at a depth at least 15 mm in excess of the expected penetration. The test should be conducted at a specified temperature of 25 degrees Celsius. It may be noted that penetration value is largely influenced by any inaccuracy with regards to pouring temperature, size of the needle, weight placed and on the needle, and the test of the temperature. A grade of 40 to 50 bitumen means the penetration value is in the range 40 to 50 at standard test conditions. In hot climates, a lower penetration grade is preferred. Penetration grade, to really define if to really define what is penetration grade, so here it is. Penetration grade bitumen are specified by the penetration and softening point test. The designation is by penetration range only. The penetration grade bitumen have a thermoplastic property which causes the materials to soften at high temperature and to harden at lower temperature. This unique temperature or viscosity relationship is important when determining the performance parameters such as adhesion, rheology, durability, and application temperatures of bitumen. So, to going back with the overview of the bitumen, so for the sources of bitumen is generally obtained from the following three sources, which is 1. Naturally occurring, 2. Extracted from limestone and sandstone, and C. From oil refineries, which includes the petroleum in the crude oils. So, to understand the importance of penetration testing, or to understand the value or the purpose of penetration testing, so the first reason is the penetration test is used as a measure of consistency. Higher values of penetration indicate softer consistency. This test, or the penetration testing, is widely used all over the world for classifying bituminous materials into different grades. Depending upon the climatic condition and type of construction, bitumen of different penetration grade are used. Commonly used grades are 30-40, 60-70, and 80-100. So the grades are 30-40, 60/70, and 80/100 over 100. In warmer regions, lower penetration grades are preferred, and in colder regions, bitumen with higher penetration values are used. So, warmer preferred lower penetration. Colder preferred is higher penetration values. The test is not intended to estimate the consistency of softer materials like cutback, which are usually graded by viscosity test. So, it has a relation about viscosity test. However, when we talk about the consistency of softer materials, it does not imply penetration testing. It implies that it talks about viscosity test. So, penetration grade 40-50 is hardest grade, and penetration grade 200 to 30 is softest grade, used for cold climates. So, we wonder if how to perform penetration tests on bitumen or in bituminous materials. So, let's have first the apparatus. So, the apparatus that we needed is the penetration apparatus, needle, container, water bath, thermometer for water bath, and stopwatch. So, the principle of this penetration testing is it measures the hardness of softness of the bitumen by measuring the depth in tenths of a millimeter to which a standard located needle will penetrate vertically and in 5 seconds. So, here is the picture of penetration testing. So, this is the needle, and the one in the blank, the black one in the picture is our bituminous materials. And in this dimension, or in this distance or spaces from here to here, it moves down vertically, or it moves vertically. This amplifies or implicates that this will be our penetration. So, while the picture below is the picture of the actual materials or apparatus of the penetration testing. So, for the procedure, first thing that we need to do is to heat the sample until it becomes fluid. Heat the sample until it becomes fluid. So usually usually of the bituminous materials are not yet are hard, or what do you call it? Are not yet in a fluid state. So the first procedure is you must hit the sample until it becomes fluid. So the second one is pour it in a container to a depth such that when cold, the depth of a sample is at least 10 mm greater than the expected penetration. And after that, allow it to cool in an atmospheric temperature, and clean the needle and place a weight above the needle. Use the water bath to maintain the temperature of specimen. Mount the needle on bitumen such that it should just touch the surface of bitumen. Then, start the stopwatch and allow the penetration needle to penetrate freely at same time for 5 seconds. Then after 5 seconds, stop the penetration. Result will be the grade of bitumen. Take at least 3 reading. So what is the significance or uses of this penetration testing? So before, about volumetric shrinkage, we defined the effect, or we defined if what will be the significance of having a volumetric shrinkage testing or performing a volumetric shrinkage testing. So right now, we will go to the uses and significance of penetration test. So penetration test is used to measure the consistency of bitumen so that they can be classified into standard grades. Greater value of penetration indicates a softer consistency. Generally, higher penetration bitumen is preferred to use in cold climate, and smaller penetration bitumen is used in hot climate areas. So to really note this in mind, higher penetration is good for cold climate, while smaller penetration is good for hot climate areas. So it also measures the hardness or softness of bitumen by measuring the depth in tenths of a millimeter to which a standard loaded needle will penetrate vertically in 5 seconds. The penetrometer consists of a needle assembly with a total weight of 100 grams and a device for releasing and locking in any position. The bitumen is softened to a pouring consistency, stirred thoroughly, and poured into containers at a depth at least 15 millimeters in excess of the expected penetration. The test should be conducted at a specified temperature of 25 degrees Celsius. It may be noted that penetration value is largely influenced by inaccuracy with regards to size of the needle, weight placed on the needle, and the test temperature. For a grade of 50/50, bitumen means the penetration value is in the range 40 to 50 standard test conditions. In hot climates, a lower penetration grade is preferred. So, that's all. Thank you.